Hello, everyone. My name is Christopher Sandoval. I'm a developer relations advocate here at FlowFuse, and thank you for joining us. Welcome to today's session. So today we're going to be talking about a pretty deep topic. We're going to be talking about MCP and AI, specifically around industrial data. So before we get started, a few items of housekeeping. Firstly, feel free to introduce yourself in the chat. I'd love to know where you're coming from, how this topic is impacting you. Secondly, this webinar is being recorded, so we're going to send a link after the session to everybody. Please use the Q&A panel for any questions. That way we don't miss anything. And also finally at the end, we're going to ask a short survey that'll pop up. Please share your feedback to let us know how the session went and to help us shape future sessions. So with that being said, I want to go ahead and start off today with a few slides. It's not going to be too much, but I want to set sort of the stage of what we're talking about and sort of get everyone on the same page. Today, we're going to be talking about turning industrial data into knowledge with FlowFuse AI and MCP. But I wanted to set the stage a little bit about where I'm coming from, where this topic is coming from. We at FlowFuse, we were just at Prove It, which is a great session for anyone who's into industrial data. It's a great show. And we gave a version of this talk and workshop, but we didn't get as detailed as we're going to today. So I really wanted to show you real quick what sort of data we were collecting and how this might level up to the kind of data that everybody is collecting, especially on edge devices. What we simulated and what we'll be looking at in a little bit today as a simulation is a standard factory. It is, mixing and packing stations. It is different systems collecting a whole bunch of different data. Often that data is super, super complicated, super all over the place. And really the critical problem here is really that we have too much data. That is becoming its own problem. To give a little bit of context about what I mean when I say too much data, there was a time, and if you are older like me, you probably remember this time, where megabytes were expensive, gigabytes even more so. And so there was, a lack of options for mass data storage and having local lakes and having all these sort of solutions. We are no longer in that state. And so for a long time, we've said, okay, we'll just collect everything, right? That's going to be the answer. The problem is that volume doesn't actually solve anything. And in many cases, it actually exacerbates the problem. You get through this process of, okay, well, industry needs to generate a bunch of data. Cool. That data ends up siloed, especially across edge devices. Okay, well, we'll figure out some way to get information from that data, right? We can take that data, we can get some information, we can get some learnings from it. Okay, cool. Well, now we have the information, but that often comes with limited interactivity. That is just sort of a static report. You get, whatever the person who's created it has decided that the report means, what you get. It's not great, right? So then the next option is, okay, well, let's surface interactivity. Let's make these things self-serve. Let's get people to be able to select what they want, get that information, and then engage with it. But that adds complexity, which is sort of, in a lot of instances, what we were trying to solve in the first place. Okay, well, we can solve this complexity by putting into place standards. But standards are also a problem. If anyone is familiar with this comment from XKCD, it is a classic. It is, okay, situation, there are 14 competing standards. Well, let's have a new standard. Let's unify everything. The dream case is that, well, now we have a standard way to interact with our data and to get insights, to get knowledge, and we can deploy all these things and do really, really well with it. The reality, the outcome of it is often, okay, now there's 15 competing standards. And that is really frustrating because the sort of general solution that we have traded on for a long time is, okay, let's do more documentation. Let's put some controls and limits into place, and let's sort of orient ourselves around processes. This will somehow get us all the industrial data in the place that we want it to be so we can get knowledge. But all of those things generate their own challenges. Even if you can abstract away the competing standards and the complexities of all these systems, you then run into, where's the answer? Where can I even find this documentation? Why am I so limited? Why can't I just work on my data? And really the fundamental question becomes, why is this so hard? And every time you have an unanswered question like that, you add cognitive load. And then the more cognitive load you have, eventually teams just stop asking. And when teams stop asking, we've just short-circuited the whole problem. So that takes us to what we're talking about today. AI, right? Let's just use AI. AI, MCP will solve the problem. But it's not that simple. And really, this is the crux of what we're going to be talking about today. The reality is that industrial AI is not magic, and it generates a whole host of new requirements. It creates a bunch of pressure between teams, and that pressure is often really difficult to balance between OT concerns, IT concerns, management concerns, let alone the training, the new systems, the new modalities. And that pressure just adds and adds and adds and adds. And eventually, the fact is, it's not a band-aid. It becomes something that you can't just deploy, and without having a framework and a way to approach this problem, you run into really significant issues. So all that being said, let's talk before I show you the sort of, hosted piece of this and the remote piece of this, the actual data connections. Um, what does good actually look like in this case, right? If we were to have a situation where we can connect all of our industrial data, where we can make all these systems work, what does good actually look like? Well, the first thing is that we need something that has practical deployment, something that is actually useful, that connects to our devices in situ, that does our information conversion in the way that we want it to, that levels context as a first-class data resource, and I'll get more into what that means in a few minutes. And it resolves both the OT and the IT concern of things. And these two things are often really hard to balance because they're in conflict with each other, right? The OT concern is universal, easy to learn, flexible. Awesome. The IT concern is, okay, well, the second you talk about universal, you talk about something that like has to be supported. When you talk about something that is flexible, well, does that mean that it's secure? Is it something that just anybody can spin up? Because if just anybody can spin up, then that sounds, alarm bells in the IT brain of, okay, we're concerned about this. So before I show you the sort of practical build out, this is the core of what we're going to be talking about today. This is MCP, FlowFuse's solution for AI and MCP. To give you a little bit of context about what MCP is, the way that I have always described it, and maybe the easiest way to understand it, is that MCP is basically a phone book for your AI. What I mean by that is when we say MCP server, MCP servers are not servers in the way that HTTP servers are. They're not servers in the traditional sense that you are hosting content and then you're sharing that content and then that content can be accessible. You can download a movie or a song or whatever. That's not really what we're talking about. What it instead is it is literally if you need this, go look for this. If you are an AI tool and you need to access a resource, here's the listing of that resource, the URI of it, the database link, the process by which you can invoke it. And then it is up to the AI to go chase that down. That also comes with the little asterisk that it is up to us to build it. And that is the complexity we'll get to today. So really quickly, this is the sort of flow on FlowFuse. Users, this is all us on the left side of things. We define tools and resources. Those tools and resources are then collected as an MCP option. That option is then routed through a bunch of different things. We have device agents, so it could be local Node-RED instances. It can be FlowFuse instances in the cloud. It can be remote FlowFuse instances. It can be all sorts of things. Once that MCP sort of flow is managed, it is then set through validation and filtering and routing, because all of these things have to be mapped to actually be secure, right? It's not enough to just say, oh, well, we can do this thing. We need to make sure that you have the right to do the thing, that you have the authorization, the authentication, all of that. Once you get to that stage, then all of the other routing happens of, okay, do we need to go to external servers? Do we need to send it to AI for processing? And then once that piece is resolved, which is, believe it or not, we're only halfway through the flow at this point, all of it then has to come back and be routed exactly where it needs to go. So that means that the model has processed the request. It'll go back through the device agent, come back to the user. So obviously this sort of layout that I'm giving you right now could be very complex, could be very difficult to deploy. And that has been the big problem with MCP up until this point, is that yes, it provides this universal connectivity layer, but you have to go through manually appending, what your tool can be called and where you can find it. And there's lots of code. If you've ever made an MCP surfaceable tool in something like VS Code, you're probably very familiar with that flow. It is a lot of work. It becomes quite difficult. What I want to show you today is this. This is going to look very crazy at first blush. The MCP tools that we're going to talk about today is this view. This is the MCP tools. I'm also going to show you a couple different options for integration with edge devices, specifically with remote edge devices. And then I'll show you what that looks like on a practical sense in terms of accessing databases and resources. So let me show you the sort of flow that you can expect. Of course, I'll clear this. So let's say we have our MCP server set up, and I'll walk you through that in a second. We can ask some sort of question. We can say, hey, what is my best performing machine? Very top level question. What's going to happen here? You can already see it popped up on the right, is we're going to generate a query. And that query is using some natural language processing. It's looking for what tool is the best tool to address this question. And we'll get into the question breakdown in a minute, because that's actually quite important how you think about these questions. But assuming just the question as it is structured now, what is my best performing machine? Obviously, we're going to have to call some data. And so get latest data service is the most likely data system that we want to call. We send the arguments and we get our payload back. Now, this payload is actually quite large. It is 15,330 rows, which is a lot of data. It's a time series database. I'll show you what that looks like in a minute. But once this data comes back in, we're basically saying to the system, hey, for the context of your question, of handling the question that I've asked you, I want you to use this array. I want you to use this context. And that is what MCP is. It's model, context, vertical. And we can do this in a couple ways. It doesn't just have to be in the format that I just showed you. It can be local resourcing. It can be external tools. It can even be prompts. But the core idea here is that we're trying to define what the MCP can do in order to answer our question. So with all that being said, let me explain what I was referencing earlier in terms of how we ask the question, because this is actually quite important. If we look at the question that we've asked, the question is, what is my best performing machine? From a human to human basis, we understand what that question is, right? That's not a super complex question. For a machine, this question kind of means nothing. What is my best performing machine? In what context? Over what time? What does it mean to be best performing? Are you talking about OEE? Are you talking about, performance metrics? What exactly are you talking about here? Let me take this up real quick. So part of what you need to do before we can even talk about building out these systems and controlling the sort of like logical data flow between them is we have to figure out what question we're actually trying to ask. So in this case, this is a relatively simple question. What is my best performing machine? If you had a more complicated question, such as, okay, for this best performing machine, who is the manager of the site that machine is part of? And is that person in office? Okay. That is a very complicated question. That is multiple pieces. So what you need to do when you start thinking about, okay, how am I going to answer that question, is to start breaking it into logical pieces, which I've done a little bit of here. So, obviously we need to retrieve the current data. That's our background for what we're asking. But I also need some site manager context, right? I need to be able to say, okay, who is the manager of site one, where this machine is located? I can infer some of that information. And in fact, if you look at some of what we're processing, I'll pull up some of the payload. You'll notice that we actually had this structured through our MQTT in an enterprise format. So we can say, okay, this is clearly part of enterprise A, it's site one, it's a vibration line, it's machine 3, and these metrics are coming from the quality endpoint. That's sensible. Okay, so we can provide context for that. We can get understanding of that. But we need to have all of the other context of who the manager is, what their contact is, whether they're in office, all of those other little pieces. Each of those pieces of the question are not part of the omnibus question. They're not something that the AI or the MCP is going to solve right away. And especially when you have thousands of edge devices, it's not something that it can just infer. You have to decide how to surface that information and break down that question. So to that end, let me jump over here. What you're seeing here is not actually an MCP flow. Let me just say that right off the bat. What you're seeing here is a couple different options that you have for edge connectivity and getting that data out of the system. I've chosen one particular sort of strategy here, and I'll show you the end-to-end way it works in a moment. But you basically have three options. Your first option is the simplest, but it's actually the most limiting for a couple different reasons. And that option is the single instance flow. Now, the way that this works, when you think about your factory, it is basically collecting all of your data into one Node-RED instance, one FlowFuse instance, and then working upon that singular instance, which sounds great, right? That's super simple. It's really easy. You have all these edge devices, send all of your data to one thing, and then form your query there. The problem is that that doesn't actually scale. If you really think about what it means to process that amount of data, the amount of data we just processed in this array, 15,000 lines of data. If I look at my database as it currently exists right now, this is called QuestDB. It's a time series database. If I look at what's coming out of this, we're already up to 15,795 rows. And it's relatively efficient to compute this as it currently exists. I will also say I'm running this on a relatively beefy computer, and so this is fine. If you were doing this at the edge, however, if you were trying to get this data, from a specific line or a specific set of machines, you're not always going to have what I have right here, which is a Mac Mini 24 gigabyte, which is not like the most powerful machine, but it is quite powerful compared to what we might experience in the field. If you're using, what we used when we were at Prove It, which is an OnLogic CL210G, I believe, that machine, if I'm not mistaken, only has 2 gigabyte of RAM. And that's quite a bit for, what we're trying to do here. But if you're putting everything onto that one node and you're having 10, 15, 20 people using MCP tooling, you're routing all the requests to that singular piece of system hardware, of architecture, you're going to run into a lot of issues. So yes, it is the most simple sort of way of doing this, but it is also the most limiting in the sense that you're putting all of your eggs in one basket. You're putting all of your processing in one place. There's also the complexity, and this is true of another example here, which I'll give in a minute, which is when you're making these requests, there is a latency. And that latency isn't always a game changer, right? If you're requesting something like OE, if you're processing OE and you're requesting availability, I don't really care if my availability is 5 seconds old. There's not going to be much change from production to production for 5 seconds. There's just not going to be much change. In this scenario, we're looking at vibration systems, right? We're looking at the amplitude of a vibration machine against a baseline. That metric actually is quite important. Okay, so quality here might not be important, but when we start talking about, performance, all of this is kind of whatever. This here, this amperage, this is quite important. And that even just the fact that this is like very, very, very important for downstream processing, it's important for context, it's important for electrical control. All of a sudden, that little bit of latency that we introduce in the single instance flow model, that is a problem. Because if you think about what it takes to get this data from generation over to the time series database, that means we're writing it to MQTT. That means we're then pulling it into the database. That means we're then querying the database and we have to wait for the query to finish. Then we're routing that query through project nodes or however we're connecting it. Sometimes we have protocol things that are playing up, especially with older protocols. I had somebody come up to the booth and talk to us about Toyopuck. If anyone's familiar with that, it's a very old Toyota automotive standard, but it is often slow. And so in those cases, you're introducing latency upon latency upon latency. And all of a sudden, the data that, was quite valuable, this amperage data, is 10 seconds late. Even if it's not 10 seconds late, if it's 5 seconds late, that's huge. Okay, so there's another model, which is actually the model that I've used here, which is called the multi-instance flow. And the easiest way to show you the multi-instance flow is just to show you what it looks like. So I'll show you the retrieve current data solution here. So the way that we've built out MCP on FlowFuse is to define things by tools, by resources, and by prompts. A tool is something that the AI can do. A resource is something that the AI can know, and a prompt is something that the AI can ask. In this scenario, we have retrieved data from time series database. We've defined this really clearly within the tool itself. We said, hey, here's the name of the tool. The tool name, which is what the MCP is going to be referring to, is Get Latest Data Service. We've defined what the tool actually does in terms of, how it processes the data. And then we've also put some annotations to basically say, hey, this is read only. You don't want it updating the database. This is open world. It's going to touch lots of different resources, and you can invoke it for this specific purpose. Now, in order to sort of remove the processing delay that I was talking about, the easiest way to do that, I'll move some of these over because this is a little bit nested. The easiest way to do that is actually to send out to the instance and do the processing right where the data is, right? That seems sensible. Therein lies, however, another blocker, and that is the context. I mentioned during the slides at the beginning that context needs to be a first-class data object, and that is especially true when you look at a flow like this that is extremely complicated you're sending out. How do you, and again, this is getting out of the sort of human way of thinking about this. Think about a machine for a moment. How do you as a machine know where this question has come from? How can you say, okay, this question is relevant to this machine, to this user, to this context? The only way you can do that is by injecting as much context as you can into the request itself. And so here, what I'm doing is I'm using a solution to basically cache the request. So the request comes in with a message ID and it says, hey, send it out to the remote instance. And while it's processing, I'll wait for the response. All of this code is going to be provided on GitHub, so you can look through it on your own. But you can see here, it's quite simple. We just establish a cache. We set some time limitations on it, and we set the project link in terms of how we're managing the MCP message. And then we send out through the project link downstream and wait for the response. Now, in this case, we're now sending out to the remote instance. And for this process, what I'm doing is I'm actually broadcasting the message out to a topic. That way I can divide what is being sent out to edge devices and other sort of local systems. I can divide what is MCP relevant or operationally relevant against what is being sent for the sort of operational context of just running the dang thing. So in this case, I'm sending the QuestDB dash request. Now, getting into the remote instance, you can see we're writing a lot of data all at once. What this is basically doing is we have all of our machines. This is all simulated, and we're writing to MQTT. And then what we're doing is we're taking all of that data from MQTT and we're basically parsing it to then go to the Quest database. Okay, so we're taking all of that data, we're structuring it to go out to QuestDB, and we're doing it locally so that everything that is being generated through MQTT is immediately available for consumption however we want it to be consumed. For the QuestDB piece of this, you can see that we have the project end node here. And what this project is actually, or this project end node is listening for, is that QuestDB request. So if you imagine a sort of network of connected nodes, a network of machines, some of them are edge, some of them are cloud. Just imagine your cloud basically calling out and saying, operator, get me, MCP data source. I need it to do something for me. The operator then connects you to it. And then now that you're connected to that edge device, you can say, okay, edge device, I want you to do all this complex functionality. Where this gets interesting is the fact that once you've broken out of the project itself from the MCP request, you can basically do anything that you want. In this context, I'm actually just doing a very simple retrieve all rows because we don't have that much data in the database right now. QuestDB is wildly efficient. And so in order to get all the context that I want, it's actually not crazy to just say, hey, select these columns from signals, order by the timestamp, and that's it. That's not crazy. If you start getting to 400,000, 800,000, a million rows, in real enterprise level data, and in some cases, like this is a vibration simulator, I have it on a 5-second heartbeat. Most of these machines are actually not 5-second heartbeat. They're much, much more frequent. In those cases, you need to start deciding how you're going to limit that data and for what purpose. And now we're getting again back to the initial sort of thing that I was sharing, which is what question are you actually trying to ask? Are you really asking across all 1 million extant data entries in my time series database, what is the best machine? That's not really what you're asking. What you're really asking is over the last 24 hours, what is my best machine? Or for this line, what is my worst machine? Or, is there any planned or unplanned downtime across my machines at site too? These questions are actually quite a bit more limiting than you might think. And because of that, you can start to break out that functionality dependent on what the question you're actually asking is, and then route that functionality through this process. So as an example, I have another function node here that is very simple, just limits to 5,000. Because QuestDB basically functions in the same way that a PostgreSQL or a SQL database would, you can basically do any sort of modification that you can imagine on that query, and you can do it programmatically. You can limit by time series within a range. You can limit by machines. You can say, select these from signals only where the key equals machine to metrics availability. So you can limit it only to availability. All of those questions, all of that can be supported, but you have to provide an ingest point. And what I mean by ingest point is you have to remember that the second you hit this node to remote instance, you either have to do the processing before you hit that node of what the question is, or you have to do it on the other side. And often you can get stuck in this idea of, okay, I've sent out the thing and now, it's good. But then you can forget like, oh, I was actually supposed to do something, right? I was supposed to ask the question. I was supposed to process the thing. Um, and so that can become a problem. We really have to think logically how these things are going to be structured. The other piece of this, and the other more sort of complicated piece of this, is understanding that this singular instance of processing is going to be invoked every single time that you send data out to the remote device. Okay. What do I mean by that? If you adopt this other strategy, which is the single instance flow, it is simpler, it is less efficient. However, you have a crazy amount of control. You have fantastic control, right? You can decide, okay, I want you to process this thing. I want this question to be asked, and I only want one person at a time able to do that. I'm going to batch it. I'm going to do all these things. Great, perfect. However, when you go to the multi-instance flow, you suddenly now have to care about all of the remote instances that is going out to. You have to care about all of the systems, not only whether those systems are accessible and maintainable and all the things that you typically have to do with sort of edge computing or edge devices. You also have to care about who else can access those devices. And that becomes pretty complicated to sort of manage this piece of it. So in order to resolve that, there is an additional solution, which is the routed multi-instance flow. Now, what is the difference between a routed multi-instance flow and a multi-instance flow? Anyone who's in the IT space, if you're familiar at all with IT, the multi-instance flow is sort of like an unmanaged switch that is just on broadcast. Everyone can access, everyone can send it out. It's whatever. Routed multi-instance is more like a managed switch, that it has VLANs, that is separated out, that has, everything sort of segmented out. You can send out to projects that are part of different teams or different applications. You can, in some cases, if you're not using Project Out, you can send over MQTT. You can send those requests that way. You can push to HTTP endpoints. You can do all sorts of different things here to manage that querying. It doesn't all have to be done in the same way. And by establishing this process, what you're basically doing is you have the MCP originator. You're saying, here's my question. It gets sent to the router. And then from there, the router manages all of the interconnects, all of the routing, all of the more complex sort of, feeding of the questions and routing of the data. The problem here now, and this is sort of getting back to the earlier slides that we were talking about, is as you get more control in this way, you start adding more complexity. The good news is you're the only person that has to manage the complexity because you're running the MCP service. The bad news is that you have to manage it because you're the one running the service. And that is, difficult. But the good news again is that you have much more control. You can route how these things process. You can actually be very deterministic about it. Again, in this flow, what I decided to do was to use this other option, which is the multi-instance flow, and to really to send it out to a remote instance. Once it's actually computed on this side, gone through the function, gone through the HTTP request. This is actually how I'm writing and requesting. Well, this is how I'm writing, but this is how I'm requesting from the time series database. It then comes back to the MCP handler and pushes that data out as the MCP response. And you can see here that every single MCP tool has that exact sort of build. It is, here's the tool definition, here's the actual meat of how we're doing all of that processing, and then here's the response that comes back out to the user. One point of clarity here, and this is when MCP starts to become a little bit of an art as opposed to a science, is that the difference between a tool, a resource, and a prompt is a little fuzzy. And what I mean by that is, I could make a tool here that is retrieve site manager data. That is a tool that could be, a thing. But is that actually useful? Because how often are we going to be changing site manager data, right? So in that case, we can just store it as a database, and I can store that as a FlowFuse table, or I can do what I've done here, which is just basically define a payload that is a JSON object and put it right in the context. If I wanted to, in fact, if you're at all familiar with context stores, I could very easily write this data as a global context and then just pull it from there. I could, have it injected as part of a payload. I can have it be an external API, which may be useful if you have like a human resources management tool that you want to pull that data from. I could define it really in any way. There's no limitation. Excuse me. There's no limitations to how you do that. Of course, that is the rub, right? When there's no limitation to how you can do something and it's not prescriptive, you're sort of left to your own standards to do it. Another good example of this sort of dichotomy is this tool. So what this tool basically does, I'll give you the sort of story behind it. If you are looking at your sites and you're saying, hey, I have this distributed edge industrial data, I would like to pull that data all into one site and look at it and say, okay, I have 2,000 sensors out in the field and they're roughly separated into geographic areas. And oh no, 200 of the sensors are reporting weird. I need to have someone go look at it. Give me some of the data about that manager, but also give me some information about the environment in which those exist, right? Because if there's like a massive storm, if it's raining, windy, then I may expect my sensors to not be giving me the best quality data. And so in that case, we do have a tool here, which is Get Current Weather, which uses an open API called Open Meteo or Open Meteo. Meteorological is the long, but Open Meteo. And basically structures that as, hey, we need this answer, go out and process it, bring it back in, process the feedback for MCP, and then give it back. And so you can start to see that the division between tools and resources starts to get a little bit murky, because when you're looking at something like the Get Current Weather tool, we could easily just continually pull that data on like a every hour basis and write it to a database. And then all of a sudden, what is our tool becomes a resource. When you have thousands of edge devices and you're pulling that data into a database, well, is that database a resource, or is the tool to access the database the tool that accesses the resource? Things start to get a little bit murky here. And I think, again, the easiest way to sort of resolve that question is to drill down to what I said earlier, which is, what question are you actually trying to ask? Are you trying to ask, what is the state of all of my sensors across all of my geographic areas, irregardless of what the weather is or what the environment they're in is? Or is the question you're actually asking, someone told me that one of my sites is down, I want to know why? Those are two very, very different questions. And accordingly, how you're going to build that is going to be very, very different. And how you're going to answer the question has to be structured different. And fundamentally, how you collect the data from your edge devices is going to be very different. The last sort of piece I want to show you in terms of the building process here is prompts. Now, prompts are an interesting beast. When I said earlier, sort of the division between a tool, a resource, and a prompt. A tool is something that the AI can do. A resource is something that the AI can know, and a prompt is something that the AI can ask. But aren't we asking the question of the AI? That's kind of a complex nuance. Yes, we are. However, when we ask the question of the AI, the question that we ask is not actually the question that it answers often. What happens when we ask the AI a question is it gets parsed, it gets understood through natural language processing, it gets restructured, and basically a whole series of mini internal prompts are what is used to actually get you your answer. The good news is that knowing that structure, we can actually exploit that a little bit and we can get the AI to do what we want it to do. So in this case, I think I still called it location trip planner from the last iteration, but this is actually a site manager message. Let's say, we've detected as we did in our flow that a couple sites are doing really well, or maybe a couple sites are doing really poorly. And we want a manager to go look at that site. We can ask something like, hey, who's the site manager? And can you tell them like I'm dissatisfied with this thing or I want them to go check on it? That is a very general question. What we can instead do is give the AI a prompt that when we invoke it, we're actually asking for a specific function. Okay. So I'll put this on a new line so you can see the whole thing. I break that down. So what we're asking it to do here is please write a message to my site manager. But the context that we're giving it is you are writing a letter to ask a site manager to check on a site. So that already sets the context for what we want the AI to do. Site manager name, which in this case is just a variable, it's a variable that we have to feed it, is the name of the manager of the site. That may seem obvious to us, but for the AI, it needs that, clarity. Be formal but polite. We're giving it an expectation of its tone. And then below, and this is actually quite important for when you get into much more complex prompts, we're defining exactly what that site manager name actually means. We're defining it as this is a string, it is the name of the site manager, it is an object, and it is required. So when we invoke this tool, the AI is going to process a few things. It'll process the request that we've given it. It'll look at the prompt and say, okay, for this particular question, I need to use this particular prompt. And then it's going to go through all of these processes. It's going to say, okay, I understand you want to send a message. I understand it needs to be formal but polite. I understand that it needs to go to this specific site manager. Oh, I have a tool to get information about that site manager. So if you ask it, okay, and put its phone number at the top, that person's phone number, it will also go to that secondary resource and it'll say, let me call that and add additional context to my processing. And you can start to see not just the prompt, but all of this. You start to see it more as building blocks as opposed to individual invocations. And that's really the power and benefit of MCP in terms of turning industrial data into practical knowledge. When you think about connecting industrial data, connecting edge devices, connecting all these systems, can you do that without MCP? Can you do that without AI? Absolutely, you can do that. You can totally do that. Where you get benefit from and where I think FlowFuse really excels is this idea of taking all of that connection and turning it into something more than the sum of its parts. I could have just a button that I push that says retrieve data from time series database. The question is, if I do that, do any of us really feel like going through 15,000 rows of data right now? I don't. I'm sure you all don't, right? Especially if this is like a 30,000 row data or even worse. Okay, let's say I do feel like doing that. Let's say there's something wrong with me and I want to comb through 30,000 rows of data. If I have 15 sites, do I really want to do the cross mathematical computation to figure out which sites have on average better performance, which ones have poor performance? Do I really want to do that? Not really. Do I want to then say, okay, well, this site, let me go look on weather.gov or whatever my, source of weather is. Do I want to go through that sort of cognitive load? Not especially. What we have here then is building blocks, not just for solutions of implementation, but of solutions for knowledge and solutions for friction reduction. Now that sounds like a lot of advertising lingo. So I'll get back to this piece of it. This piece. The core problem that we're trying to resolve is that every solution that we could put in place to resolve some minute piece of this broader industrial data connectivity problem, documentation. Okay, where does the documentation live? Well, I can ask the AI in this case because we've built in all of our data, because we have support. I can ask, in this case, if I wanted like, how do I install an S, or how do I get data from an S7? I can ask the RAG system on FlowFuse for that answer, and it'll go through everything and it'll pull that data out. We can do this exact same flow of sort of like contextual information gathering on the Insights tab. We can ask, okay, I understand that I'm having poor performance on this site. Which machines are responsible for that? And against their documentation of their tolerances, against their production information, against their recent like repairs and their planned and unplanned downtime, are those machines actually performing to where they should? Is this an outlier, or is this something that is more sort of habitual and long term? I can now get that information really, really easily. When we get to things like controls and limits, why am I so limited? Why do I have to go through this process of looking through Atlassian to find the like one little piece of documentation that somebody put for a piece of unplanned downtime? Well, now you don't have to. You can ask the MCP and say, okay, were any of my machines, do I have any unplanned downtime? And I'm actually not reporting that within this data set, but if you have that data, that can be reflected back through and you can actually get that information. You can get that context in a handful of seconds. And then finally, that process orientation. Why is this so hard? I really love this implementation because this whole piece alleviates the friction of where do I even ask that question? And especially when we're talking about industrial devices that are on the edge, that are distributed, which device do I even ask? Where do I ask the piece of information? Like, where do I get that from? Within this structure, you no longer have that problem. It is surfaced to you. The context is surfaced to you. And I think that is really the key here, that what makes MCP work, so what makes this offering really work, is context. And so what I want to leave you all with, as I said, all of this is going to be on GitHub. It's going to be shared after the fact. Definitely go check out all the code, check out the flows. Also check out the Road to Prove It videos that I've done over the last couple of weeks, because there's a lot more of this and a lot more granular build down or build out. When you start to look at the finer details of surfacing data, it really comes down to two things. It comes down to knowing what you're trying to ask. That's sort of problem one. The other piece is knowing how to answer that question and knowing how not to answer that question. Because you could just throw all of the data at the wall. You can connect literally every device that you have and hope for the best, which is sort of how people are doing MCP right now. But that doesn't actually do anything. That doesn't get you any sort of insight. That doesn't get you any sort of contextual value. If instead you break it down into discrete pieces, and then you use all of the context that's within FlowFuse that is generated as part of FlowFuse. In fact, I'll show you a great example of this. If you look at any of the queries that we've been generating, you can see that each one of these pieces comes with not only the data set, it comes with the node that has requested it. It comes with the message ID. It comes with the event that generated it. It comes with the timestamp. All of this now becomes what is referred to as meta contextual information. That context is now not just like a nice to have. That is the additional context that gives you complete observability, complete monitoring, complete sort of top-down view over the entire system. That makes your context a first-class data object. Suddenly now you know exactly what's happening in your system, where each question has come from, and how it's being answered. So that is the sort of crash course. There is a lot to talk about here. This could be something that is like 10, 20 hours of its own course. It is very, very deep. But right now, I'd like to answer the floor to any questions that anyone may have. If you have questions, if you want to see any particular solutions built out, I would love to share that with you. So yeah, go ahead and any questions. I see one just popped in. I want to see it again. The webinar will be available on demand. Yes. So if you have registered for the webinar, which you should have if you're here, you will get a copy of it. This will go up on our YouTube. And as I said earlier, there's also a lot of documentation about this on the Road to Prove It playlist, which I'll share. I'll share that and the GitHub to everybody. So yeah, there's a lot that you can go through. Now, I do have a couple polls that I'd like to share with everybody. The first question I'd like to ask, real quick, is your level of familiarity with this topic. So coming into this, or even just sort of generally speaking, I want to know everyone's level of familiarity with AI and MCP on the industrial level. And the reason I'd like to know this is I noticed specifically at Prove It, there are a lot of people who had very light sort of exposure to this, but did not actually understand the full potential of what we're talking about. Um, and it is a very heavy topic to get into. So I'll just give a couple seconds for everyone to have a chance to answer. Yeah, it looks like most everyone here is just exploring. There are a handful of people who have implemented pilots, which is very cool. I will say also, one of the difficult things about MCP is the quality of the pilot that you implement can very drastically impact how good this tool looks for you, especially if it's something that you've only just now started using. It could be something that on first blush looks useless, and then you look at your implementation after the fact, and you're like, I didn't implement it right. That could be a thing. Yeah, so it looks like the lion's share of people are just exploring, although some have implemented pilots. Awesome. Another question for you all. Let me go ahead and share with you all that question. I would also like to know the kind of hardware and data that you're trying to collect. And specifically this question for you, I would like to get an understanding of, is this on the edge and across all systems? Are we looking broader at standard data and sensors? Are we looking at legacy data and sensors? Are we looking at cutting edge data? It is interesting to me to see what kind of data people are actually collecting and what they're trying to do with the system. Because I will note that one of the, I shouldn't say weaknesses of this approach, but one of the challenges of this approach is that it works very well with modern data, but when you're using legacy data, you actually have to do quite a bit of remixing. That is a big challenge of using MCP. Is you have to, again, you have to know the answer that you're trying to get. You have to know the question that you're trying to answer. And in order to answer those, you need to know the full kind of data that you're supporting to answer that question. Yeah, so it's looking like, actually, it's about 50-50. So most people, somewhere around 60%, um, standard data and sensors. So things like Modbus, OPC UA, and TPP, which is cool. But there's also a ton of people, I'd say 40% actually climbing a little bit. That is a mixture of data and sensors. And that is something that I'm finding pretty broadly when I talk to people about this, is the challenge of combining different kinds of data and sensors, not just in terms of different modalities of collection of data, whether it is vibrational data, visual data, those sort of things, but also just the modernity of data, especially across older factories, older systems. I will say the good thing about data in FlowFuse is that anything that is a message can be interfaced with MCP. It may seem a little bit weird at first to think in that way, but once you start looking at like, okay, what question am I actually trying to answer? And then what am I generating to answer that question? You start seeing like, oh, OCR actually is generating a message. Contextual data is, NFC is generating a message. Cool. The last question that I wanted to ask you all is actually about our next webinar. I love feedback from the community. I love doing these sort of like highly technical dives. I have a couple different ideas, and I'd love to see what you all think. The first one is integrating APIs and external agents specifically. I think that is a very complex question because it determines a lot of what you can do is dependent on external APIs. Obviously, using the FlowFuse option, you're using our implementation, which is great. But if you want to use custom models, ONNX models, if you want to use Claude or whatever, then you have to start doing quite more complex computational things of surfacing data securely. It becomes much more complicated. Running AI at the edge is also very, very complicated because now we're talking about like actual edge computation. And I'm sure anyone here who's used PLCs knows that like running an inference model on a PLC is a nightmare. That's not a thing that you can do. And so figuring that out is quite complex. Deploying AI-ready data models, that is getting quite a bit of feedback here. That is also a big topic. And AI governance and production reliability, that is also a relatively large topic. It looks like most of you are quite interested in the integrating APIs and external agents. That is a very heavy topic. I think all of these actually have some videos that I've done in the past, specifically integrating APIs and external agents. If you want to check out a video I did that was developing a council of AI in FlowFuse, I used several different AI agents to sort of argue with each other to get the best response. But obviously, there's much more to APIs and external agents than just chatbots. But you may find that interesting. Um, well, perfect. That is great feedback. We'll let you all know soon what the next month's topic is going to be. I really appreciate your feedback. So yeah, that is this session. Please let me know if there's anything that you would like me to build out specifically. If you have some specific use cases, please let us know in the comments. Please let us know in the chat. I love building out sort of one-off demonstrations of this tech. So I would be happy to do that. If you'd like to explore everything that we just shared today, as I said, I'll share the GitHub. I will also share the setup process for setting up QuestDB. All of this was run on Docker. So if you have Docker, you can go ahead and do exactly what I've done here. I'll show you the images and everything and how to do that very shortly. And also, there is a link to a short survey that's popping up. That's only going to take about a minute. Your feedback is really helpful. And I did just see another question popped up, so I'll answer that before we close out. As someone new to this topic, are there any example use cases to base pilots on? It's very open-ended, so it'd be good to know what that looks like. There are actually a couple really good examples. I can give you one example for me. I'm in California. California people represent. Part of the challenge of living in a place like California or Utah or Nevada is water scarcity is unfortunately a thing. And I can say that one really good example use case to base a pilot on would be the use of remote edge monitoring systems and tying that to additional context. So we actually had a pilot out here that connected to a bunch of different edge devices and said, okay, water quality is low, water availability is low. What does that mean? Let's compare all of the data from the different sensors to open API data for, okay, was there a recent fire? Is there any sort of, pollution detection, air quality detection? Is there anything that we can pull together as a contextual piece of data that then gives us some sense of, okay, with all of this in mind, can we now look at what may be causing low water availability, low water quality, especially during fire season? That's very helpful because I don't know if you're all familiar with fire cycle and water cycle. Once you get ash into the air and it settles on the ground, that does affect ground permeability, and then you do have water issues downstream. So that's a very good pilot. I think another good pilot to look at would probably be the solar industry. The solar industry has used this quite a lot, not only for just-in-time manufacturing, because when you're using a lot of rare earth materials and things like that, to be able to know which orders are coming in, whether you're meeting that sort of takt time goal, and then also what the average sort of cost per unit is. I've seen this also being used on the monitoring side of things, of tying together, here's the panels that we produced, and it says that things will pay off over X number of years. Okay, well, let's do the actual computation and say this panel is rated at this power generation limit. Here is what the APIs are saying for the average sun that this location for longitude and latitude got over this period of time. Does production actually match with the rated production? And is there any sort of improvements that we can make for the solar positioning that can improve that production? Now, that case in particular, I believe, was out of the Netherlands, but there's also things like that have been piloted in the States for angle control for massive solar farms. But there's a million use cases. If there's a problem that you face, chances are MCP and AI can help you. Chances are it can also hurt you. So you have to really think about how you're implementing it. But it can make your process much better. So yeah, if there are no other questions, I want to thank you all for your time. I really appreciate all of the feedback from you all. As I said earlier, there is a link to a short survey. We would appreciate your thoughts. And beyond that, I am just so thankful you all joined, and I will see you next time. Until the next deployment.